Hi, Miss Ackerman. I'm
Very sorry for this. It's due to time difference.
No. We are just about to start, so I think you joined right on time. Welcome.
Thank you so much. Thank you so much.
So
hello, everyone.
Hello. So if dear participants, colleagues, if you allow me, I would like to officially launch today's webinar. We are very happy to have this event in collaboration with the Swedish Waste Management Association. And today we have Wayne Wickenvist to be our dear moderator for today's event. And Mr. Wickenvist is an international expert on waste management and policy making. He has also been working extensively on waste management issues in Sweden, in the European Union, and other countries around the world. He's now serving as part-time senior advisor with the Swedish Waste Management Association, where he served as managing director for many years. So today we are very glad to invite Wayne to moderate the session. So I'm going to hand over to you now, Wayne. Thank you.
Thank you, Shane, and for that extensive introduction. Thank you very much, and welcome everyone to today's seminar with the topic name Bio-Waste Alchemy, Transforming Municipal Waste into Green Gold. We have the ambition today to present challenges and opportunities, to focus on the high quality recycling, and to present lessons learned. We have a number of distinguished speakers and panelists from Europe, Latin America, Africa, and South Asia. We have 90 minutes, so I think we should start immediately. And I'd like to invite Mrs. Louise Herman from SIDA, the Swedish International Development Agency, to bring her opening remarks to all of you. Please, Louise.
So, hello, everyone. Thank you so much. I'm sorry about the delay. So my name is Louise, and I'm the lead policy specialist in environment and climate at SIDA. And today I have the pleasure to welcome you to this webinar on Bio-Waste Alchemy, Transforming Municipal Waste into Green Gold. So I'm very excited to be here today and learn more from you about innovative solutions on bio-waste treatments and discuss how we can contribute to the circular economy through transforming waste to wealth. The interconnected triple planetary crisis facing humanity, climate change, biodiversity loss, and pollution and waste are putting the world's economic and social well-being at risk, while undermining the ability to reduce poverty, improve lives and livelihoods. With the rapid population growth, urbanization, and changes in consumption patterns, it is estimated that waste generation will increase enormously by 2050. And the implications, as you all know, of poorly managed waste and low levels of recycling and reuse of resources has an enormous impact on human health, the environment, and socioeconomic development. And it is evident that local authorities and municipalities has a crucial role in the delivery and transformation of waste management. So considering the size of organic waste in municipal waste, particularly in developing countries, having a sound strategy on organic waste is a key element of any zero waste planning. And it has impacts in terms of climate action as well as sound management of waste. Sweden has one of the longest experience on the path to zero waste. That is very interesting, and it would be very interesting to share lessons learned from and with other countries aiming towards waste prevention and reduction. From Sweden's experience and EU waste directive, source separation of waste is particularly important for effective recycling and to avoid that waste ends up on dump sites and landfills. So bio-waste is particularly important to reduce and sort separately due to methane gas that the bio-waste creates in landfills. Hence, bio-waste management is an important aspect of circular economy. So, SIDA is supporting waste management in several contexts, and in particularly in Eastern Europe and Western Balkans. And one example is Ukraine, where President Zelensky especially has requested Swedish support on waste management. And SIDA is currently preparing a package of support focusing on both national policy level with the EU accession process as a driving force, as well as the municipal level, where Sweden will build on Ukraine's successful decentralization reform, which is ongoing since 2014. And I know that one of my colleagues was together with you, Mr. Winquist, to discuss this in Ukraine. And UNDP. UNDP is a key partner to Sweden broadly and to SIDA specifically, and both in its broad development scope and within joint climate and environment work. And SIDA is supporting UNDP on nature, climate, waste, energy, including on the subject on zero waste and circular economy. And this webinar is organized in the context of this cooperation. So now I really am looking forward to learn more about solutions and how to transform municipal waste to green gold. So thank you very much, and I wish you all the best in this seminar, and I'm looking forward to learn more.
Thank you very much, Louise Herman, and especially...
Sorry, I don't know if you saw me properly, but that's not so important.
Very good, very good. Thank you very much, and especially your introduction regarding the situation in Ukraine. And well, this afternoon's webinar is structured this way. So first we will have two, let's say, keynote speakers, Professor Mats Eklund and Dr. Jane Gilbert. And that will be followed by a panel discussion with three panelists from Sri Lanka, representing Colombia, and also from Ghana. So our first speaker is Professor Mats Eklund, Linköping University in Sweden. Mats Eklund is professor in environmental technology and management. He leads a research in group Industrial and Urban Symbiosis. He's also the director of the Transdisciplinary Biogas Solution Research Center, a triple helix center of excellence involving 50 private and public organizations, and has been involved in this sector for 2 decades at least. Welcome, Mats. The floor is yours.
Thank you very much, Veine. I will directly just start sharing my presentation then. Let's see. No, I don't see it myself. How should I do that in order to actually share my screen? Share this one. This one. Yeah, sorry.
It's okay.
Thank you, Veine, for the kind introduction. I have a lot of things to say. It's always like that when you get a chance to talk about biogas solutions. So the last like 15, 20 years, I've tried to come to some conclusions regarding challenges of implementing the Nordic biogas model, but also something about the societal effects that it relates to. Well, let's go. I think it's a bit difficult for most people that are not in the sector to understand about what is really biogas and biogas solutions, because it's not very tangible. It's very seldom you get a chance that I got together with a colleague to get inside one of those anaerobic digesters, but we're actually inside one there. So you see where that one will be filled with a nasty slurry of source separated waste from households, organic waste, maybe food industrial waste, or even liquid manure or something. And there, the organic matter will be decomposed by microorganisms, and you see these bubbles on this screen. Those bubbles represent sort of the methane that is being formed, an energy carrier, a renewable energy carrier. And as you may also know that when you have done this process, you will have a digestate that will typically be useful as a biofertilizer. So I'm based in a city called Linköping, 160,000 people living there. And the history of biogas more or less started, I would say, with wastewater treatment and the need for hygienization of the sewage sludge. Later came also a need to take care of difficult, wet, problematic waste from slaughterhouses, from dairies and other sources. And later also introducing the separated organic food waste from households, here represented by these green bags you see here. So in our city, we put all our organic waste that we have in our homes in a green bag, which will be sorted optically and separated from the waste that will go to an incineration plant, while the organic matter goes to the co-digestion plant for biogas. So this is where I'm active in this system, more or less. When you have produced the methane, it is typically used for transports. I'll come back to that a bit more, but public transport, cars, trucks have historically been used in compressed gas. Nowadays, we see also a growing market for liquid biogas. And what's left would be the biofertilizer, which actually feeds all the commercial large farms in our area. We also see a lot of other activities. I mean, we have a lot of consultancy, we have a lot of research, there is a lot of things in a growing sector around these kind of solutions going on in our city. However, when you move around the world, like this image from Fortaleza in the northern Brazil, 3 million people, you see the skyline there, and this is the largest, we are on the top of the largest landfill there. 750 trucks come every day with mixed waste that is just landfill. Actually, this landfill produces as much biogas as the plant in Linköping. But I think the potential would have been so much bigger if the organic fraction would have been separated, and we would have had many other advantages. Cities like this around the world, of course, are facing so many different challenges, and really serious and big challenges. And here are some examples you can see. And what you normally don't maybe think about is that actually biogas solutions can address all of them at the same time. They won't solve everything, but it definitely can address them and contribute to the solving. And we talk about a Nordic model for biogas. Why is that, and what is it? Well, it's just to bear in mind that it's started as a waste management issue. Then we have the digestion processes. Then we have the upgrading of the methane to clean biomethane that becomes something that we can operate our transports with, a renewable energy, but also the renewable nutrients. So when we have all these components together, we of course, we came up with this idea that let's call it Nordic biogas model. I think it's globally relevant though. And if you apply this in your city, I would say you get a lot of different effects, of course, relating to energy side. Here you see the blue part, the nutrient aspects, and the waste management. So you will have these 3 services and products coming out of the system, which in turn also generates, of course, other effects on a more societal scale, more green jobs, better public health, etc., etc. Just to remind ourselves, okay, this is what happens if you take care of the organic waste separately, you use gas for public transport. This is like kind of some of the societal effects you may achieve. In most cities, we put still a lot of the waste on landfills and we operate buses on diesel, you get none of these positive effects. Going into composting could be at least definitely a first step on this road. Then you would have the nutrient and the waste management aspect, but you will miss out on the energy supply part, of course. You could also consider, of course, you could incinerate the waste. You can actually produce electricity, and you could use your operate your public transport with electric buses and even have some advantages, but you would miss out on the nutrient aspect. I think you see the big picture, I hope. When it comes to climate, you know, we have in Sweden an annual report for all fuels. And for 2022, the average emissions of CO2 equivalents was 0. So now we're talking about 0 emission in the whole life cycle perspective. It's not 0 emission like all these, you know, emissions elsewhere, vehicles, etc. This is like 0 in the whole life cycle. How can that be? Well, of course, there is a substitution of fossil fuels. But there is also an avoided methane emission, we heard also from before, and we are allowed in Sweden now to account for the manure part there. Then there are some other benefits that are typically not included in the administrative systems, but of course, we're also substituting fossil nutrients. We're also building up net soil carbon by adding biofertilizer to the soil every year. And there are also effects related to anaerobic water cleaning. So if we sum this up, you could say that in a city, if you employ this Nordic model for biogas, you would have some climate-related emissions. You see the first bar there saying production. That's 7 kilos per person a year. But the fuel substitution effect would be -30. The avoided landfill would be even more. And also there are contributions from the fertilizer substitution and the soil carbon buildup. So for me, it's amazing how little we hear about biogas solutions in the climate discussion. I don't understand why. Yeah, I do, but for now I say I don't understand. So if you want to understand the societal effects of biogas solutions, I would say you would need also a wide framework for your assessment. We've tried to evaluate and understand the societal effects, and by employing, for instance, we have 16 Swedish environmental goals or the UN Sustainable Development Goals. And basically, of course, the broader the assessment, the better the result will be for biogas solutions. And what we more often do is to focus maybe on one problem at a time, trying to solve that, where we are also, I would say, typically take a big risk of coming into what we call problem shifting. We solve one thing, we create a new problem. But here, this is a way of sort of addressing that. So what we learned over the years, I would say, we started from waste treatment, a very much of a hygienic focus. It moved on to, energy and climate. We started talking later also on circular and bio-based economy and started to understand the value related to the nutrient flows. And today, we're more or less come all the way to think about that there are a lot of different direct and indirect system effects on the whole city or a whole region. And I would say biogas solutions to me now is more or less of a sustainability tool. So these are some things about the development. I think you could note that co-digestion plants is the kind of plant that we saw in the beginning, that is the growing part in this system. Wastewater treatment generates some gas as well. Landfill is going down all the time because landfilling of organic matter has been banned for a long time. So there is less and less gas produced there. And industrial plants and farm scale plants, we see increasing interest recently. And some policy background to this would be, if I have to choose a couple. First of all, of course, the landfill ban of organic waste, a core policy measure. We also have what we call climate investment grants in Sweden, up to 50%. You want to build a biogas plant, the government can pay you like 40% maybe of that investment. And biogas solutions come out in those evaluations as very competitive. We have a tax exemption for using it as fuel over time, and we have national goals for collection of food waste. But so these are like more enabling national policies, while I would say that those who did it was more the local and regional authorities, because they saw the benefits. They saw, let's try to connect these parts of the system and create a policy integration between different policy areas. I'm talking about transport because it is what has also been a very important part of financing the system, because fuel is expensive in Sweden. Electricity is here very cheap. And most parts of the world you come, I would say transport is the best market. You see, when it comes to the compressed gas, on the left-hand side, it peaked around 2014, and it since then has been quite stable. Today, it's difficult to get cars. The interesting thing here is also the green part. 97% of the compressed gas sold for vehicles is renewable. So there is 3% fossil natural gas still in the system. We see also on the other side with the truck here is the liquid gas. Just the other day, the figures for 2023 arrived, and they included a doubling again. So Scania, Volvo, and Iveco are three brands of trucks that are really stressing the potential of liquid biogas, which makes it more or less having the same range as a diesel truck, but without emissions, more or less. I can't go into the policy, but you will just have to get an overview saying that, of course, these are areas that are influenced by many administrative levels. Many parts of the value chain can be a part of it. And there is also a lot of different sectors that are involved. And we've had a problem with the temporal dimension. Policies have been introduced, but they're short term. So this picture, just I would summarize it by saying, if you're in the biogas sector and interested in that, you can be sure that there is at least always something wrong somewhere in the system. So we have this Nordic model. It integrates, I would say, wastewater treatment, waste management, transport, and nutrient recycling. And I suggest it has global relevance. But of course, there is also another part of this, which is more the agricultural side. Crop residues, intermediate crops, and creating a more resource-efficient bioeconomy. And of course, it's great if these two can meet, then we can take the sustainability potential even further. So I would go very far in stating that one of the big problems we're facing is that the reason why still a lot of the resource and pollution problems grow is because sectors and supply chains are separated in different silos. People are in agriculture, in horticulture, in livestock raising, or in waste management, or in transport. But the beauty of biogas solutions is that it reconnects the different parts of what should be a coherent system. So last slide, summing it up, biogas solutions has a much wider positive sustainability handprint than all other options. If you do it correctly, there are very few conflicting interests. It has much better climate performance than all other options. You could even reach negative emissions, below zero. Biogas is expensive to produce. That's why willingness to pay has been highest in the transport sector, and that's why it has been very important. It's a very fragmented and sensitive policy area. I would say it needs special attention by that. And the last observation from where I'm standing right now is that increased demand and production of biogas actually drive and finance a lot of environmental improvements. Thank you very much for your attention.
Thank you very much, Mats Eklund, professor in Linköping, Sweden, for this very good presentation. And we will come back later on concerning the issue on steering instruments and policies, because of course that is a very relevant aspect as well. And I was especially delighted to see the image of the city of Linköping, because that is also my town where I grew up earlier in my life. So that was very good as well. But we will have a few questions for you, Mats Eklund, later on, but I think we go directly to the next speaker, which is Dr. Jane Gilbert from Carbon City Group, and she is also the chair of the International Solid Waste Association ISVA's working group on biological treatment. Dr. Jane Gilbert holds a bachelor's degree in microbiology, a doctorate in biochemistry, and an MBA. Jane Gilbert has been involved in the organic recycling sector for over 25 years, and she has a lot of experience in bio-waste recycling standards, certification program, and so on. Welcome, the floor is yours.
Thank you very much, Rainer, for the introduction there. I'm going to talk a little bit about preventing and managing contaminants in organic waste recycling. And this is some work that we've done recently with the International Solid Waste Association, which is how I know Rainer. And ISWA is the world's leading network promoting professional and sustainable waste and resource management. And it has over 1,300 members. And these members are located in over 110 different countries, as you can see on the little map here. And there are also regional chapters as well that people might be interested in joining, depending upon where you happen to be based. So that's a little bit about ISWA. So why am I working with ISWA and doing this work? Well, a few years ago, in conjunction with two of my colleagues, Marco Ricci Jurgensen and Aditi Ramola, we did some work on soils and looking very specifically at the impact and the benefits of putting compost and anaerobic digestate onto soil. And first of all, we did a global assessment of municipal organic waste production and recycling. I would very much like to update that again in the future. We then did a second report on the benefits of adding compost and anaerobic digestate to soil and looked at, well, what's actually happening there, and tried to summarize a lot of the scientific findings into a readable document. We then did a report summarizing the state of soils in 5 different countries, and we tried to scatter them across the world. So some in Europe, we included Chile and also Australia as well, and looked at what is happening and what are the drivers there. And then finally, we did a 4th report trying to quantify some of these benefits, because they're very difficult to quantify in many respects and really require natural capital accounting mechanisms. So once we'd done all of that and we'd finished with that work, we then very much tried to think, well, what are the really important things to look at? And contamination and contaminants in organic matter, in bio-waste, and in compost and soil and digestate were really important. So that is where we carried on, and we did some work and published a report in October of last year, which when it was launched, on a practitioner's guide to preventing and managing contaminants in organic waste recycling. And all of these reports can be obtained free of charge as PDFs from the ISWA website. And I'll send you, there's a QR code at the end of this talk as well if you miss it. So first of all, why is contamination important? You have contaminated bio-waste going in, and here's an example of about 10% contamination, with the biggest problem there being plastic film in the form of bags, and also flexible films coming from packaging. And once the contamination's in there, it's very difficult to get it out, either through processing or in the outputs. And it affects both composting and anaerobic digestion equally, coming through into the compost and digest state, which ideally we want to put back onto soil to benefit those soils, either as a soil improver or as a biofertilizer. And why is it important? Well, the main reason is because it is soils in which we want to grow our food, in which we want to grow foods for animals, for us to eat, but also for our pets. And it's also important because there's increasing evidence now that some of these contaminants can actually move up the food chains. So moving up trophic levels and being concentrated as it moves up in a very similar way to DDT that was a big problem in the 1960s. So there's basically three different types of contaminants. We've got physical contaminants, as you can see here, plastic fragments, plastic bottles. Plastic is a big problem. Chemical contaminants, ones that you can't see, and also potentially biological contaminants as well. And in the document, we focus on all three of these. So as I mentioned, the physical contaminants are really the plastics. They cause us the major problems. They're the major problems for operators of anaerobic digestion systems, facilities, because they not only affect the end products, but they very much affect the machinery and the equipment used. And you saw the impellers in the photograph that the previous speaker showed with him inside a tank. Well, they block them, they prevent the mixers from working properly. And the chemical contaminants as well, and there's a big crossover between the two. But with regards to plastics, we also have microplastics and then nanoplastics being formed. And these there's evidence now that these are actually entering the food chain and being concentrated as they move up. So potentially a big impact here, not only on ecological systems, but also for human health as well. The other major issue at the moment, the burning issue here, are the per and the polyfluoroalkyl substances, so-called PFAS, or forever chemicals. And these are present in a lot of food packaging. So we can wrap our foods up in products that contain these chemicals. And what happens is they end up in our food waste, they end up in our bodies, but they also end up in compost and digest state as well. And once again, there's now real concern about them entering the food chains. And finally, biological contaminants. These can come from pathogens and parasites, plant toxins, but some of the biggest problems come from invasive species. And the photograph here shows Japanese knotweed, which is an invasive species that has been introduced into the UK, and it is really, really difficult to get rid of. And you can see in this photograph here where it is actually managing to break through the concrete and grow up through concrete. So it is a real problem. So these are some of the biological aspects that would need some attention. So I think one of the main outcomes that we've done through publishing this report is developing the contaminant management hierarchy, and just with other hierarchies as well, including the waste hierarchy. There should be prevention right at the very top. So preventing contaminants from getting in really should be the preferred mode. And that includes selecting stocks carefully, ensuring that there's separate collections and good communication. Then if they are present, it's removing them wherever possible before treatment, then during treatment, and then after treatment. And the least preferred option is not removing them at all. And I think that was mentioned as well in terms of mixed wastes and treating mixed wastes. So we describe this in a lot more detail in the report. Prevention, we talk very much about the different types of collection scheme that can be put in place, of which are very much in place now within Europe, but in other parts of the world, Africa, Asia, collection schemes are just starting to be looked at and put in place. Collection tools as well, in terms of whether compostable, certified compostable plastic bags or paper liners are being used to help householders and businesses collect bio waste before it is actually collected in trucks and taken away for treatment. And also public awareness initiatives, and we talk about some of those as well in the report. We've also included a number of different case studies, and these are in the back, and we've got 4 different case studies, including one from Sweden, and where we've looked at different types of bio-waste going in, food waste, but also food and garden waste, looking at the ways in which contaminants are managed before they are put into treatment systems such as composting or AD, and then the treatment after processing as well. And what we've tried to do is summarize some of the key data here as well, in terms of the amount of food waste going in, the ability for contaminants to be removed pre-treatment and then after treatment. But if you look here, we've got 92% pre-treatment and 5% post-treatment. It's never possible to remove 100%, which is why reducing and minimizing the contaminants going in right at the beginning of the process is so important. So in the report, we put in place a call to action across the sector, both in terms of equipment suppliers, but also bio-waste treatment companies, composters, anaerobic digestion operators, and municipalities, and for them to really improve research and development, to improve the methods and efficiencies of removing and preventing contaminants from entering organic wastes, and thereby ending up in compost and anaerobic digestate. So I think I'm just up to my 10 minutes allocated time. This is a copy of the report, and I think this QR code here should enable you to take you through to the part of the ISWA website where you can download the report for free as a PDF. And if you do have any other comments or questions, please do either ask me in the question and answer part of this, or contact me afterwards. But thank you very much for your attention.
Thank you very much, Jane Gilbert, for this very good presentation. And I believe the issue on quality recycling is, of course, a general issue for all kinds of recycling, but it's more critical, I would like to say, for organic recycling than compared, for example, for paper or scrap or whatever, because we are not going to eat them. So it's very important that we have this classification and a good quality. Before going into the next part of this webinar, the panelists, I wanted just to give you a few questions, Mats Eklund and Jane Gilbert, and perhaps we also will have the time to go through maybe some question from the chat. You know, there is also chat where people can put questions, and there is a question and answer session. However, I feel sometimes a little bit uncomfortable because, you know, if you go and look to the chat and the question and answer the whole time, you split your views and you have no idea actually about what the panelists are saying, which is actually intention with the whole webinar. So, well, anyway, Mats Eklund, given your experience, which do you think are the 3 main obstacles for achieving a sustainable management of bio-waste? If you can elaborate that on a little bit more general level. You are muted.
So
Yeah.
I think I would say the first thing I think was in my presentation is that you of course need to stop landfilling. I mean, as long as you can landfill something or you can discharge it into the river or whatever, it is very simple and very cheap. So nothing can compete with that. So you have to stop sort of the landfilling. So that's of course quite an important challenge, I would say. The second thing I would say is you need to break the silos. What I mean by that is waste management people need to talk to wastewater treatment people, and you need to talk to those who are involved in transports. You need to understand the farmers. You have to go outside your normal comfort zone where you normally meet people in your own silo, because this system involves different parts of society and they need to be a part of the development. The third thing, of course, my presentation was stressing the opportunities, of course. One of the things that you also need, which I didn't stress, is, of course, build capacity. I mean, we're talking about fairly well-established technologies, not very, very difficult, but you would still need people that know a lot on like aspects like Jane Gilbert just spoke about, and how you develop the system in terms of creating a cleaner biofertilizer, etc. So stop landfilling, break the silos, and build capacity. And build capacity, hopefully also through partnerships. And that's why we are here from Sweden, because I think we have something that we would love to share with other parts of the world. It's not very easy. It requires a lot, but see us as possible partners for the capacity building also.
Thank you. And if I go to you, Jane, and the same question more or less, which are the 3 best advice you will give in order to build a sustainable market for compost and biodegastate?
Okay. Well, the first aspect is quality, quality, quality. Nobody wants to buy a poor product. People will always want to have a product that will give them value, that will help them. And the main market sector for compost and anaerobic digestate is the agricultural sector. So farmers operate on very low profit margins, and they're very quite rightly risk averse, that they can't afford to damage their soils and they can't afford to lose crops or have reduced yields. So quality is really one of the most important aspects. And it's not just about quality in one batch, it's about consistent quality. So trying to identify and meeting an acknowledged and agreed standard in terms of quality, but also having in place a quality assurance system to make sure that every batch of biowaste is treated in the same way, so that it is treated to the right time temperature profiles, and so that any problems can be identified and rectified. And there's also a full traceability from the biowaste coming in to the compost or digestate going out to the field in which it has been put on. So that's the first aspect. The second aspect is information. Information is really important so that people know how to use the products. Compost and digestate have 2 very, very important differences. Digestate is more of a biofertilizer, so it provides a good range of plant nutrients, especially the macronutrients, in a very plant available form. Whereas compost is more of a soil improver. It will provide longer term nutrients, but they're less readily available to farmers for the crops. It's more of a soil improver, adding that organic matter back. So very different products. So farmers need to understand what the differences are if they're going to use them or want to specify using them. So information, and there's an awful lot of information out there now in the scientific publications, but also in more readable, less scientific publications that have been translated from scientific papers, such as the ISWA, one of the ISWA papers that I spoke about. And the third aspect is demonstrating. If you're going to be selling compost and digestate or trying to build relationships, especially with farmers, with horticulturalists, with farmers and the growers, you need to develop a good working relationship with them. It's not like, for example, buying a loaf of bread or a litre of milk or something where you can buy it from one person one day and another shop the other, and it doesn't really matter. You don't have that relationship with the companies that are selling you the products. With compost and digestate, it's different. So you need to build a relationship. This is all about relationship marketing and showing and demonstrating to the buyers that the products that you're selling will work in their soils, on their crops, in Sweden, given the type of environment and the climate that Sweden has compared to, say, the south of Spain, or, for example, in Chile, in South America, or, for example, in Mongolia or Indonesia or somewhere. You always have to demonstrate to farmers, to local farmers, that they work on local soils with local crops and can be integrated into local farming practices. So demonstrating that, giving away some of the product free, putting in place demonstration plots, building ambassadors. This is like long-term relationship marketing. So I think all of those three things, quality, information, and relationships and long-term marketing strategies, are what is needed for sustainable markets for both compost and anaerobic digestate. So that's summarizing what's quite a long and complicated subject in a few minutes.
Fantastic. Very good. Thank you, Jane. And referring to the chat, if you have the opportunity, Mats Eklund and Jane Gilbert, to look into that and see if you can perhaps answer some of the issues, it will be nice. Of course, we will always have this discussion about large scale or small scale, and it's always the case that there is no one silver bullet solutions. The situation is always different, containing the different conditions, of course. So now I want to go ahead with the actual panel, and now we will have three panelists from different parts of the world. And our first panelist is Mr. Manju Dissanayake. He holds a Bachelor of Science of Engineering degree, and he serves as the municipal engineer at the Kaduvela Municipal Council in Sri Lanka. He has a distinguished career spanning over 7 years in waste management, construction and transportation sector, and extensive experience knowledge implementing sustainable waste management practice. So I welcome you, and you are welcome to take the floor, Mr. Dissanayake.
Oh, thank you. Thank you for giving me an opportunity for this event. Okay. Could you mind give me the co-hosting for the sharing? One just reads I log in to device. Hello, can you hear me?
Hi, I think I've just give you the
Yeah, I log into the two devices. Because of that, can you give me the for this device what I on the mic?
I'm sorry, I don't get the question. So you're saying you cannot share your
Yeah,
presentation?
I can't share the screen. Yeah,
Oh,
the problem
okay.
is disabled. Yeah.
Okay, maybe I can do that from my side then.
Yeah.
Or maybe Livia, can you do that from your end? I just realized that
Yes.
Okay, good, thank you.
Yeah, I'll try.
Okay.
Go ahead.
Okay.
Okay. Can you in a presentation mode?
Yes.
Yeah. Okay. Hello everyone. Good evening. According to my time, I am Manjushri Sanaka, municipal engineer from the Kaduvela Municipal Council. I'll be present the how Kaduvela Municipal Council manage the bio-waste briefly. Next slide, please. Firstly, I give the brief introduction and the characteristic of the Kaduvela Municipal Council area. Kaduvela Municipal Council is the largest municipal division in the Sri Lanka. It consists with the 57 GN divisions and population around 281,282 distributed across 75,985 families. It is subdivided into 3 key areas according to the development pattern and the administrative purposes. When considered the Kaduvela area, it is developing area and the mostly flood affected area. When considered the Battaramulla, it is developed and most government services are provided in city in the Sri Lanka. When go to the Atrugiri area, shown in the it is highly residential and fastest growing rate of residential development in Sri Lanka. Yes, next slide, please. This slide shows the process of waste management in Kaduvela Municipal Council. There are 2 sections, biodegradable and non-biodegradable sections. Daily waste collection in the Kaduvela Municipal Council range from 60 tons to 70 tons with the communication through the cleanup mobile apps, and it will help the segregate the waste according to the requirements. When considered the bio-waste, it is from the total solid waste, it is about 35 tons per day. Non-biodegradable waste are managed is according to the slide shown in the side bottom. It is, I'm not going to explain the process and mainly focusing the bio-waste management process of the Kaduvela Municipal Council. Daily 7 to 8 ton, 10 are used for the composting process according to the demand, but capacity is more than that. We can produce more than that composting process. For considered the electricity generation from the biogas, 80 ton of bio-waste is utilized for the biogas production through the anaerobic digestions. The biogas project is collaborative project between KMC and the UNDP and a milestone in a sustainable waste management in Sri Lanka. As a byproduct of biogas, liquid fertilizer is used for the agricultural purpose in the particular area, and try to promote the liquid fertilizer at particular area. The electricity generation from the biogas project is connected to the national grid due to that is addressed not only waste management issues but also energy crisis in Sri Lanka. But from the remain of the bio-waste, 5 tons are directed to the composting process at the pig feedings outside of the premises according to the requirement of their requirements. Other remain around is 20 tons are directed to the Sri Lankan Land Reclamation Development Corporation dump site at the Kerala. Considering the from that one, considering the sustainability, it is not good practice, hence required for the expanding the biogas and composting project in our premises. Can we go next slide? Then when considered the capabilities and project details, this is the biogas unit. This is the pilot project which connected the national electricity grid Sri Lanka. The project cost is about 20 million. And 50% from the project cost is bared by the UNDP and other half from the Kadwila Municipal Council. Average feedback for the biogas unit is 160 tons per month. Average production rate, average electricity generation is nearly 1,400 to 1,800 kilowatts per month. Because of this project implementations, average monthly saving from the electricity bills, waste transport cost, and also the tipping cost for the dumping is saving around 287,500 per month for the Kadwila Municipal Council, including the maintenance cost with the net metering. When considered this one, it will be more profitable with the next net accounting process and the KMC request for that one. From the above cost saving, the payback period of this project is about 5 years and 9 months. When considered the composing process, that are also the cost saving project for the Kadwila Municipal Council. It is saving around 225,000 for the Municipal Council for the transport cost and tipping cost for the dumping. Next slide, please. Challenges are facing lack of awareness of separation at source. Because of lack of awareness, it is sometimes biowaste also contain polythenes and some kind of non-biodegradable waste in the biowaste. Because of that, it is some challenges to we have to address. And also the technological challenges also have, because of the for the maintenance and construction of some kind of things related to the biogas production. Then liquid fertilizer disposal also problem, because we can utilize for the cultivations and other agricultural purposes, but the requirement is not sufficient. Not requirement, demand is not sufficient. Financing also may problems because of the funding allocation of the fund for this process. It is also the approval process is challenges for the Kadwila Municipal Council and also the Sri Lankan. The target is to improve the public awareness of and participation of the waste segregation process to the from public. And also the required is expanding the capacity electricity generation from the biogas, because of our bill according to the electricity bill of the our premises. And also the liquid fertilizer promoting system is also required for the project. And also finally, improvement composting technique to extend the product quality, because that means value addition is also the required for our project. Thank you very much. Next slide.
Thank you very much, Mr. Disselmayake, for this very keen presentation. And I think we will come back later on during the panel discussion, especially to your concluding remarks, the last slide that you showed for us. So now I wanted to invite the next panelist, which is Mr. Noah Jima. He holds an MBA in Banking and Finance, a bachelor's degree in Mathematics, and a Project Management Professional Certificate. And Mr. Jima has over 20 years of experience in capital markets, and he's presently the Chief Investment and Climate Finance Officer at Jospong Group of Companies, where he leads investment and sustainable finance strategies. Welcome, Mr. Jima.
Thank you very much. I appreciate it, Wayne, and thanks everyone for the opportunity to share. Jospong Group of Companies is a conglomerate in Ghana with over 65 subsidiaries, but the key business lines is in the waste and environmental sanitation area. The project of focus for our discussion is integrated waste recycling and composting plants, 4 of which we've been able to focus on in the last year during COP28. We were able to obtain carbon credit with offtake from the Swiss government, working with the United UNDP. And so in terms of organic waste treatment, I mean, this diagram really depicts exactly what goes on in our plant. The structure of our composting is just not only one here, but we have 16 regions in Ghana, and in all regions we are investing in this recycling plant to ensure that at least we'll be able to treat them and also compost as much as we can. So as you could see in this diagram, our process is from end to end, from waste collection at vintage points, whether from domestic, municipal, and then also from hotels and others. And we transport them, some of them through transfer stations, directly to this compost plant. And as all various speakers have said, it's just the sorting is always a challenge, but we have them at our plant, and then we go through the composting process. What we've been able to do, I'm sure during the discussion, is our ability to extend the composting into new innovative products that we constantly develop. And so if you want to talk about our success or our ability to do composting from end-to-end waste collection in Ghana and other West African countries that we are already operating, and we continue to look for opportunities to operate. So you look at it in the context of these 4 plants. That's where we're doing the composting, which entered into the program with UNDP and Swiss government. We would like to share with you some of the key parameters around this project. So we're looking at the ability to produce about 13,000 tons per year of grade A high quality organic fertilizer, really increasing agricultural productivity. We're looking at, as we talk about circular economy, be able to create over 1,000 direct jobs for these 4 plants. And each of these plants is taking about 400 metric tons a day of waste. And if we process them, we are yielding this tonnage of grade A organic fertilizer. And then, as I mentioned earlier on, being able to go further to develop additional product, taking them from solid to liquid fertilizer, and then also other byproducts. The focus of our plants, and when you go there, you see that we want to make sure that at least we would have empowerment, women empowerment, and then even youth as well, to be able to really get into composting. One of the key parameters in terms of educating is really catching them young, and then also making sure that at least the behavioral changes in terms of even beginning to sort from at the point of collection are all incorporated in our plan going forward. But at least for this, we are anticipating creating 1,000 jobs for these 4 plants at our various composting facilities, and 1,000 more indirect jobs, because there are other people that have opportunity to help with the collection, and others with their own tricycles, which give them additional opportunities for income and also for income mobility. Indirectly, about 2,000 households are in coverage area of this, what we call ARICOPS integrated recycle plant. For all this, we anticipate to reduce about 1.5 million CO2 when all this project is done by 2030. And we've already seen, we believe that at least payback period over 7 years, return on investment is very positive due to additionalities that we've added to make sure that at least we'll be able to make this. And without the ITMO support, Europe probably would have had a negative MPV, but we are able to do this and invest in technology that allow us to be able to do this composting well, and then be able to scale going forward. As I mentioned, this is only for 4 plants, but we'll have 16 of them. And so these are more like a pilot, but because they are in section already, they give us opportunity to be able to do this, not only in Ghana, but across other African countries or other countries that may be of interest using our experience to be able to do this. So in a nutshell, we look at situations where we are able to advance the investment in technology to be able to add more value to the solid composting, be able to do more in liquid composting, and then also be able to add value not only with the municipal solid waste that we gather, but we are able to even add, other material, virgin material that help to increase the value of the composting, like coconut husk that we are combining with some of this liquid waste, solid waste, to be able to add more value for specific areas of application that we've learned do quite well, like in cereal production, in vegetable production. So those are some of the key things that we are having. The challenges are quite similar to what the previous speaker said. The sorting, the knowledge, the investment that you require to be able to get the quality that you need. And then also making sure that you have the continuous government collaboration to ensure that at least you will be able to do the investment with an offtake from everyone else that you do. So I just want to thank you very much for this opportunity to share with you our experience. And I believe that during the panel discussion, we'll be able to add more if there are questions. Thank you.
Thank you very much, Mr. Jima, for your kind presentation. And we will revert back in a few minutes to the panel discussion. And now we go to the last panelist, and I would like to welcome Dr. Hiroshan Hetiarachi. He is globally recognized leader in environmental sustainability, waste management, and geotechnology with over 25 years of diverse experience. And he works together with UN capacity development programs as well. Please welcome. Yeah, it looks good.
Okay, can you hear me as well?
Sure.
Yeah, okay, great. My name is Hiroshan Hetiarachi. Thanks for the opportunity to talk about the Green Containers Program, GCP, launched by Cajicá Municipality in Colombia. I need to make a correction. I have no affiliation to Cajicá Municipality or to Colombia. This was based on a case study we analyzed a couple of years ago when I was at the United Nations University in Europe. In the interest of time, I'll just briefly talk about the project very briefly, and I'll just say a little bit about the things we found. Cajicá is a community located about 40 kilometers north of Bogota, the capital of the country. And I think the current population is about 80 to 90,000 people. GCP started in 2005 as a pilot run. Basically, the idea was to distribute a specially designed bucket, so-called green buckets, green containers, so that people can separate their organic waste and put it in the bucket and keep it in a safe way until they're collected. So this is all about source separation, which is a good thing. And the full program was launched in 2008, and between 2008 and 2014, about 15,000 containers were distributed. That tells you something about the success of the program. And the result was actually immediate, and the landfill disposal showed immediate decline, which is a good thing. Organic fraction of the remaining waste that still went on to the landfill, it dropped from about 55% to 16% by the year 2014. Well, this success was recognized by many, and among them was the United Nations Environment Program, because they recognized, they listed Cajicá as an example among few other cities in the year 2017. And that's when we had our attention to. That's when we decided to do the analysis as a case study. I did this with my former colleague, Christian Rivera Machado from Colombia. And then we published published it as a book chapter in a book edited by me and two of my co-editors. One of them is Dr. Serena Cauchi. Christian and Serena both, if I'm not mistaken, they might be in this audience today. Well, very briefly about what we saw. I'm not going to read out all of them in the interest of time, but what you see in black is the strengths, I would say, and what you see in red are the weaknesses in our opinion. I'll just touch upon one or two of them. Finding the correct business model was a very positive thing. They went for a public-private partnership type of program, which worked out very well. And the stakeholder involvement was impressive as well. They somehow managed to involve people, starting from the kindergarten to the retirees and many other entities like government entities and private organizations, schools, universities, you name it. And the best thing about this whole experience is the technology adaptation for local conditions. I'm not talking about composting. Composting plant was just like any other composting plant in the rest of the world. I'm talking about this collection process, how they manage and designed it. Especially this container was a very low-cost solution. It's just a bucket with a lid and a false bottom to collect leachate. And they also used a chemical substance called bokashi to contain the odor, because the buckets are supposed to be kept in-house until they were collected. So it worked out very well. About the weaknesses, I would say the unhealthy dependency on municipality funding was a weakness, because the municipality has been spending or had been spending about $360,000 each year to run the program, and they had no desire to charge it to their clients or to the residents. So if something happens to the funding or if something happens with the will of the municipality to fund it, program goes down. And if you, well, actually, I want to say this. All these observations were as of 2018. So my co-author or my colleague, former colleague Christian, tried his best to get in touch with the folks at Kahika Municipality, and our understanding is that the team has changed. So our efforts of getting in touch and getting more information were in vain. I hope the program is still there. I don't know, but when there is no communication, it is usually a bad news. If you need any further information, the publication that I showed you here is a free, it's an open access book. Anybody can download. You're free to download and read it. Well, that's about it.
Thank you very much for your very good information. And I think it was specifically interesting that you focus on the collection part of it, because this is something that is sometimes a little bit neglected, because we tend to look into different kind of technologies for the treatment or the recycling without thinking too much about the collection, because everything starts actually with the collection, we all know. So I wanted now to invite you all three panelists, Mr. Disanayake, Mr. Jima, and yourself, Dr. Hetiarechi, to a little short conversation. Unfortunately, we are running a little bit late, as it tends to be during this kind of very hectic seminars. But I think that we learned quite a lot indeed anyway. So in order to keep track on timing, I wanted to just ask you at this moment one question and give the floor to you to elaborate just a minute or so on this question. So my question, and I wanted then to start with Mr. Disanayake, Mr. Jima, and you, Dr. Hetiarechi, in the end. So which are your best advice to anyone who wants to follow your initiative? If we go to you, Mr. Manju Disanayake, do you have any good advice?
Yeah, we are initiate the biogas electricity generation project. my first advice is starting segregation awareness for the public according to the waste characteristic of the particular area, because the that awareness is based on should be based on the base characteristics of the particular area. The other thing is the do the feasibility studies considering the financial available payback period of the project. By considering these T1 it should be initiate the project because of the financial capabilities and the approving these type of things are it is necessary to consider for the before starting initiate the project. And also the awareness about the bio liquid fertilizer, because of this is the byproduct of the biogas productions. Because of that it should be identify the possible option to analysis what we have to do, what are the possible options we have to do. Because of that we have to do the pilot project should be done, identify the what are the quality and also the specification of the liquid fertilizer usage of the particular area. Yeah, okay, thank you.
Thank you. If I then give the same question to you, Mr. Jima, which are your best advice to anyone who want to follow your initiative? And of course, there is big risk that some will be replicating the first speaker, but if you would like to try, go ahead.
Yes, thank you very much for the question. Yes, I think that the best lesson we say is intentionality and continuous investment. It's intentionality in the sense of focusing on what problems you are solving, and that allow you to be able to continuously invest in the area, even if you're not necessarily getting your, green gold or carbon credit yet. That allow you to be able to invest in new technology, in new ways of doing things. And so being intentional about some of these projects and investing in areas of making sure that you're solving the problems of sorting, or you're solving the issues that have to do with proper composting and adding more value to it is very, very critical. So I think that, and then also building capacity. It's very important that you have a team of people with diverse backgrounds to be able to help from a technical to financial and others, so that at least you'll be able to make it commercialized. You can commercialize your activities and you can get recovery for what you're doing, not recovery in terms of being the quality of what you are producing, but in terms of recovery of your investment. So I think these are the key things that I'll mention as important lessons that could be helpful to others.
Thank you very much. That was very helpful. And finally, for you, Dr. Hetiarici, what would you add to this?
Well, I think I already touched upon two of the points about the business model and the technology adaptation before. But I want to add one more thing. And well, I already disclosed that I was only doing this as a case study. It's not like that I was there together with them. But answer to your question, Wayne, will depend on who you're asking the question. Are you asking the business side of the, or are you asking a business organization, or are you asking a public organization? The Manju's example, and I think my example from Kahika, we were looking at it from the municipality's perspective. In Noah's case, I think it's from the business perspective. But I think my advice based on this example, as well as many others that I have seen, is that policy and the political support is very important, especially when you're trying to do something like this in a developing country. Well, a blessing and a curse at the same time. Political will is important when there is a good leader with a vision. It works out very well. But can we sustain the program for very long? That actually depends on whether you can frame the whole network in the right policy context. If you are able to do that, then it will run, actually. So one last thing I would like to add is, when it comes to policy adaptation, there are different levels: country level, and then the regional or the provincial or the state level, and then the municipality level. Usually, if you wait until policies are crafted and given to you on a plate by the authorities from the federal level, it takes time. But municipalities have a lot of capacity to do things in their own territory, in their own scale, and a lot of people have not realized that we are not actually capitalizing on that flexibility. I think that's what made the difference in Kahika. They took the initiative. They made some changes into their policy, and they embedded into their fabric of how they run the operations. I'll stop.
Thank you very much. And of course, you are absolutely correct. And it always leads to my conclusion a little bit that I think that every time when we discuss this kind of activity, it ends up with governance. It's always more or less about governments. We need to solve all the issues concerning policies, legislation, finance, funding, capacities, as named before by Mr. Jima, for example, because whatever it takes, we do have the technology. Today we have showcasing a lot of interesting solutions, but without the right kind of governance, there will be nothing at all. Fortunately, we have been able to showcase very practical and positive, innovative, good solutions, and I'm very glad for that. So we are now going into the end of this webinar, and therefore I wanted to give the floor now to Mrs. Xiaofang Xu, who is the Director of Chemicals and Waste Hub of UNDP, to give some final remarks. Welcome, Xiaofang.
Thank you, Vinny. I hope you can hear me.
Sure.
Dear colleague, as we come to the end of this webinar, I would first thank our distinguished speakers for sharing your passion, expertise, and insights and experiences on organic waste management. Throughout this webinar, we have delved into the status of this issue in the world and solutions models in different countries and best practice in this area. Waste recycling, composting, and conversion to biogas. And the speakers highlight the positive impact and benefit of sustainable organic waste management, including reducing the pollutions, protecting the land and the soil, keeping the nutrient loop, creating the new drops, and mitigating the greenhouse gas emission, and many things of that we can see if we can find this kind of innovative solutions. And the more we think of the status with solutions, the more we are inspired to take actions towards a new sustainable pathway. Organic waste recycling is a powerful tool to tackling the triple planet crisis, climate change, biodiversity loss, and also the pollution. So our speakers has underscored the importance of addressing the organic waste challenges in cities and also in communities in all of the region, as a best practice apparently are at small scale, and therefore the potential is also huge. Concert effort from all levels of the government, private sector, communities, and the financial institutions, financial company are needed to make it happen at scale. UNDP now is promoting integrated waste management towards zero waste and zero pollution in all regions. In our view, organic waste recycling should be prioritized in the waste management program in cities, given its significant volume and importance to the waste collection infrastructure. Effective organic waste management will lead to the dramatic change of the current waste management system, including their infrastructure away from the landfill and the different operation models. So it will lead to the change of the budgeting and investment direction of the cities. So we saw the quick change from the plantations of the Nordic model and other solutions in the city, building on the success of organic waste recycling in demonstrating communities, cities, municipalities could develop the solutions for plastic and other waste stream, because this need to be done hand by hand, and applying the same principle, the waste hierarchy and circular economy, and advance the waste practice in whole economic activity. So as we reflect on the discussions and learning from today's webinar, let's take on the challenges ahead, engage with stakeholders, and leverage the knowledge, insight, and partnerships gained from this webinar to move forward pilot initiatives. Together, we have the power to transform challenges into opportunities and to create a more sustainable future that leave no one behind. In closing, I would express my sincere appreciation again to our moderator, Mr. Wing, our partner, Avfall Sverige, and distinguished speakers, Mr. Lois Herman from SIDA, also our partner, and Professor Mats Eklund from Sweden, and Dr. Jean Gilbert from ISVA, also our partner. We did I think, a very excellent side event in Stockholm 50 conference. And Mr. also Dasanalia from Sri Lanka, it's our focused country in Asia, and Mr. Gima from the Jospang Group of Ghana. It's very interesting presentation from you. I believe many our participants will go to you for your experience in the future. And also Dr. Harishan, and from your experience and case study in Colombia. Thanks for your time and invaluable contribution to this webinar. I also want to thank all the participants here for your time and your active engagement, and definitely we will work together in the future in this field. And finally, I want to thank the colleague in our hub, Etienne, Singh, and Livia, for the excellent work to deliver this webinar. Let's continue to work together to drive the positive change in all cities of this world. Thank you, and have a wonderful day.
Thank you, Xiaofeng.
Thank you very much.
And I just wanted to close to remind about that you can find some good information also in the chat about all the documents from this webinar, and also perhaps if you have the opportunity to share the information of this course, which is what we call the Zero Waste Vision course, especially designated for decision makers. So please look into the chat, and I agree with Xiaofeng about what she said already before about all the speakers and the colleagues within the UNDP. Thank you, everyone. Have a nice day and goodbye.
Bye now.